Ladies and gentlemen, welcome everyone. I am Dr. Roland A. Drolet, PhD in Biomedical Engineering from the University of Toronto, 1971. I am the developer and inventor of the RUMART PEM system that has helped over 1 million people all over the world who were suffering from all kinds of health problems. Hello everyone. So now I'm going to try to give you a little historical introduction about quantum mechanics. At the origin of quantum mechanics, I talked in the earlier presentation about Max Planck. So this is really Max Planck, this German physicist, using one equation of statistical physics showing that the number of electrons in the excited state in any atom, you have what we call the ground state, okay, and excited state, okay. So if an energy pack HF is shot at the ground state, it will be excited, okay, and then there will be return to the ground state with the emission of a photon. If it goes to a higher state, there could be 2 photons. But the number of electrons in the excited state over the number of electrons in the ground state, from statistical mechanics, it's always given by the E, which is the base of natural logarithm, 2.1828, at the power HF of the photon, the energy of the photon, divided by the thermal vibration energy. Okay, so this is from statistical physics. And now, if we define the average number, n with a bar here, the average number of photons with energy HF, okay, at equilibrium, when the temperature is T, the emission and absorption rate are equal. So the number in the ground state multiplied by the average number of photons in that state, okay, multiplied by the probability that is in this state, is equal to the number in the excited state multiplied by n plus 1 times the probability to be there. Why n plus 1? Because in this state, excited state, not only spontaneous emission occur like in the ground state, but there is a possibility that an electron goes from ground to this one state. So that's why there is n plus 1. So when we use these 2 equations given in Feynman volume 3, this Richard Feynman famous physics book, when we use these 2 equations and we solve for n average number of atoms in the state at temperature T, we end up with this, okay? So this is the average number in that state of energy at temperature T. Now the energy of these n photon HF is therefore n times HF. In other words, the number of electron in that the number of photons in that state multiplied by the energy of 1 photon. So we have the energy of the photon in that state of temperature. Now, I'm going to show you in the next presentation how from this equation Planck arrived at the spectrum of light emission. Okay, here we have the reference to the volume from Richard Feynman that I mentioned about. So we have the number of electromagnetic vibration modes in the interval delta F, in a small interval of frequency. It is given by, the number of mode is given by the volume of this that is present, or the number of mode per volume is given by this. And always you have this number of mode that has to be multiplied by the equation we had in the other sheet, and you will end up with the energy or delta energy in a given range of frequency or wavelength will be given by this equation. This is the equation of what we call the electromagnetic spectrum of a black body, and if you plot HF over KT to the third power multiplied by 1 over e to the power HF over KT minus 1. This looks complicated, but anyway, if you plot this in as a function of HF over KT, you realize that the maximum will be at the value 3. You will get maximum emission. So without going into much detail, this is just giving you an idea how Planck's genial physicist arrived at his theory, and he called the HF energy pack a mathematical trickery, because he thought it was so complicated that he did not want to work in this anymore. Okay, now if you are still with me, I'm going to show you a well, what we could call a mess of equation. We were talking a little bit before about this, but this is really trying to relate many things about the creation and annihilation of matter and photons of energy that we were talking so much about in the previous one. So Einstein's equation of a particle, the energy of a particle, or the square of the energy of the particle, is given by this equation, coming from mc squared, that is squared, okay, for the energy of the particle with respect to the center of mass. Now, because there is a momentum, if the particle is moving, then Einstein defined that the total energy of the particle would be the momentum multiplied by the speed of light, and this is square. Now, the momentum has been defined by Bohm, as David Bohm, a physicist, as the quantum momentum is the mass times the velocity, but plus a factor which is the charge of the particle multiplied by the what we call the vector potential that gave birth to the magnetic field, okay, or that is associated with magnetic field. So because when a particle hits another particle, there is like an induction of a field, just like when an electric current is cut off in an electric circuit, okay, it gives rise to a spike of voltage and magnetic field, okay. Now, Paul Dirac, the other physicist, have tried to explain what happens with the matter and antimatter. As a matter of fact, he is the one who invented the term antimatter. He hypothesized that the energy could be a constant A multiplied by momentum plus another constant multiplied by the mass. Okay, and now he arrived with complex matrix algebra. He arrived at different conclusion on matter and antimatter. Now what I've done, this is what I call row-draw equation. I simply use high school mathematics to write E square starting from Dirac's equation. So it's a square of the first term, square of the last term, which is Einstein's equation. But there is an intermediate factor here that is combining the two. When I equate this E square, okay, to Einstein's equation, which I say equation Einstein equal equation row-draw, it is fascinating to see that if you work the mathematics, simple mathematics, you end up with solving a second degree, what we call a quadratic equation that has a solution given by the formula here, where P is the momentum defined by Bohm, and A, B are the constant of Dirac in his equation here. So if we just suppose that, as we see, they're working, yes. If we just suppose that A and B, A is much smaller than C and B much smaller than C squared, we end up that this term is negligible and this term here will be dominant. And when we solve for the velocity after the collision of two particles, for instance, we end up with the previous velocity before the collision plus or minus c, the speed of light, multiplied by a vertical vector which represents the photon. So here we have the vertical direction which represent the imaginary plane, where you have a photon in one direction and a photon in the other direction. On the right side you have the matter, the phenomenon of matter, and on the left side antimatter. So to make it simple, this is just visualizing the fact that when two particles hit, like two electrons, one matter, one antimatter hit, it generates two gamma rays, if they have enough energy, in perpendicular direction. And if two gamma rays would arrive in hitting each other, it could create two electrons, one of matter, one antimatter, with a positive or negative charge. So this could be verified in Emilio Segre's book called Nuclei and Particles, with the editor Benjamin, W.A. Benjamin, published in 1965 in Amsterdam. So you see here the equation of one positive electron, one negative electron, giving two gamma rays, electromagnetic. So you start with something that has matter, which is transferred to electromagnetic energy. So this gave rise, this kind of equation that I arrive at here, very simply. Really, it gives rise to the famous Feynman diagram. When you have different particles hitting each other, you have like a Feynman explained in his book, and he was awarded a Nobel Prize for this American Californian physicist. So this is about what I wanted to tell you about converting light or electromagnetic wave to matter, and from matter to energy. As a conclusion to that, we could say that the predominance of matter in our universe cannot be explained with quantum mechanics and even Dirac equation, because when matter creates, there is always equal part of matter and antimatter, and there should be as much matter as antimatter, but in our universe, matter dominates. So it leads me to the conclusion that there must be another universe that is predominantly antimatter, and the two of them are plausible, so we can think of millions and billions of universes like ours, some of matter, some of antimatter, and this is coherent with what the historic Buddha mentioned when he was talking about an infinity on an extremely large number of universes, as well in the infinitely small as in the infinitely large. Okay, so thank you for listening, and I hope you keep studying this subject if you will. Okay, I'm still at it with the introduction about quantum mechanics. So this is to show electrical engineers and physicists, really this is a specialized sheet showing what we call the impedance in electrical circuit, which is a real part, like the resistance of an electric stove, for instance, and it has a complex part, which we call the impedance of, let's say, an inductor, a coil, or a capacitor. Okay, so this is related to what we talk about the resonance of the vacuum to any electromagnetic frequency, because when we are at resonance with the capacitive and inductive parameters of the vacuum, of the electromagnetic vacuum defined by the dielectric constant and the magnetic permittivity, then when we are at resonance, we get the inductance impedance, okay, equal to the impedance of the capacity or the capacitance. And so when these two are equal, we are at resonance, and then the resistance of the air to the motion of electromagnetic wave is zero, but the impedance, what I could call the parallel impedance, would be infinite. That's why it's not a short circuit, but it can only move perpendicular to the electric field. So actually, I'm not going to go into all the details of this, but you have the definition of capacitance, inductance, and with the impedance equation, if you equate this to zero, then you get the parallel case or the series case. So as we have seen on another sheet, when it's parallel or in series, we have visualized here as a tunnel of vacuum where electromagnetic wave travel freely in this direction, which can be deviated a little bit because of gravity from Einstein's general theory, but there is no, at resonance, there is absolutely no current short-circuiting the capacitive effect of the vacuum, because inductance and capacitance exchange energy, but they don't consume energy. Okay, so this is about the end of what I wanted to talk about, and to summarize about the practical application of this. We have talked about the Raumart waveform, which I've called the life waveforms, which are very similar to those of the nervous system, like the nerve action potential, and here it's similar to the current impulse through the cell membranes. And the parameter, which was the radius of the parallel plate condenser I talked about, is related to the Raumart time constant by the speed of light. And this Ramat time constant is defined in the Ramat US pattern. Okay, so thank you very much for listening, and this was a rather specialized presentation, this last one. So this is intended really for engineers and physicists rather than everyone. But if you want to read about it, you're welcome. So that's the end of this clip. Thank you for your attention. I hope you enjoyed it. And please keep smiling till the next clip.